Okay, so today we're doing business applications, means we are going to be working with money. And when we work with money, we are interested on some key principles. When we look at the cost function, we represent this with capital C. Please note the difference because there is a function that we're going to represent with little c, which is the average cost. Okay, so capital cost, capital C cost function represents the cost of producing an X number of units of whatever product we're interested in. The marginal cost is what we call the derivative, the rate of change, the rate or the cost of producing one more after we've already produced a certain amount. Okay, so it's the rate of change is what we call the marginal cost. When we're looking at the average cost, hopefully you can see that this is a common sense kind of an equation. We take the cost of X units, we divide it by X. That's your average cost of how much things, what's the average of one unit. Okay, so importante, très important. I don't know how to say that in French, but let's pretend I did. Okay, if the average cost is a minimum, then the marginal cost is equal to the average cost. We're going to use this idea. If the average cost is a minimum, then its derivative will be equal to the average. So here's an example of what that might look like. It costs in dollars of producing X 5 kilogram bags of flour. This is the function of how much it costs to produce bags of flour. Okay, find the average cost, find the marginal cost of producing approximately 100,000 bags of flour. Okay, so average cost is little c of X. And the way that we find it is by taking the cost function and dividing it by the value X. Here, we are interested in the cost at 100,000 bags. So we're going to use that in place of X. So this is going to be 1, 4, how many zeros? 1, 2, 3, 4. 140,000 plus 0.43 times 100,000 plus 0.0. How many zeros is that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1 times 100,000 squared. All divided by 100,000. You okay? Silly. Okay, hopefully you can kind of see we can make our life easier by canceling 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Or actually, we can cancel out 5 zeros and just move a decimal over here. This will make typing into our calculator a lot easier. This is going to be 1.4 plus 0.43 plus, is it 1?
Yes.
No, well, not quite. This one has 6 zeros, so 0.1.
There's 5 zeros. There's 5 zeros.
Did I miscount?
There's 5.
1, 2, 3, 4, 5. Yeah, so it cancels out all the zeros, but it moves to here. Yeah, it's 0.1. That's what I said. You guys are crazy. Okay. Throw this in your calculator. What do you get? No, I already did. 0.00001 times 100K is 0.01, or sorry, 0.1. What I'm saying is I did this in my head, and it's right here. Hey, feed to yourself. Realize I'm recording this and putting on YouTube, and now the world knows that I have an 18-year-old who can't keep his hands and feet to himself. 17-year-old, sorry. Come on, behave. Do some mental math. What is this? 1.93 what? Almost. Per bag. Yes, so this is so the average cost when producing 100,000 bags of flour, the average cost is $1.93 per bag. Okay, now let's take a look at what is the marginal cost. Marginal cost is the derivative at 100,000 K. So what we need to do, and I have run out of room, I'm going to do it off to the side here. What I want to do is compare this with what is the derivative after making 100,000 K. So what I'm looking for is C prime of 100K. Okay, first tell me what's the derivative. One, two, three, four, 5, 2, X, right? And then I put 100,000 in here. 1, 2, 3, 4, 5. So this will be 0.43 plus 0.2. $0.63 per bag. Okay, so what this is telling me is if this company produces 100,000 bags of flour, it costs them an average of $1.93 per bag, and the next bag that they make will cost an extra 63 cents, not $1.93. Does that make sense? This represents the rate of change. It is the cost of making the next bag of flour. This is the average cost of all the bags. Okay? So now in part B, at what production level will the average cost be the smallest? And what is that cost going to be? So I want to know how many bags of flour do I need in order for the average to be minimized. And then I want to know what's the average cost. So I'm looking for 3 things, okay? There are so many extra desks. Move. The both of you can move. Now I'm not discussing this. This is below my pay level. Okay, so in order for the average to be the same as the minimum, we know from the box at the top of the page that the average will be equal to the marginal cost, meaning the average will be the same as the derivative. So we want to set this up. C of X over X must be equal to C prime of X. So we know that C prime, we already did it on that top part, is 0.3 plus 0.000002x. And then on the other side, I'm going to get 4 zeros over x plus 0.43. Oh, I didn't give myself enough room. Plus 0.1234551x. Oh, I still don't have enough room. Okay. Can you confirm that I have all my zeros in the right spot? So I took my original function, I divided each piece by x. So this is the average cost without knowing what the value of x is, and this is the derivative cost. And now I'm trying to solve for x. So ugly numbers, but essentially I have a linear function, soon to be a quadratic function. Why will it be a quadratic? There's an x in the denominator. I don't like working with denominators, so I'm going to multiply everything by x.
Why not just cancel out the 0.43 on both sides first? And just, you can just subtract the other one, make it easier for yourself.
Sure, let's do it your way. You want to collect like terms and then get rid of it.
Yeah.
Okay, so you want to say 1400 with 4 zeros over x equals 0.123451x.
And then not see.
Oh, so much easier. Look at you guys thinking all clever and such. Okay, we can do this in one step then. What's x?
That's 0.1.
374,165 and 74 cents.
Yep. 5, 1.
Whatever that is.
Yes, no, but you're right. You said the right number. Okay, so in order for this to be minimized, we need 374,166 bags of flour to be produced. This is the production level that would minimize the cost. I'm going to trust that you check that this was actually a minimum. Okay, if that is the production level, how much is it actually going to cost? What's the average cost at that level? What's the average cost? We know how many need to be produced. What's the average cost? You substitute x. Yep.
Into the cost function, right?
Yep. Not the cost function, the average
The
cost
average
function. Yes. So now I want little c of 374,166 bags. What do you get? I'll start you off. $sign per bag. Round it off correctly because we're working with dollars here. Make sure your brackets are in the right spot. Make sure you're typing it in carefully. Type it in your calculator. What do you get? $1.18. Good. Beautiful. Okay, so again, the cost function and the average or the marginal cost function are both on your formula sheet. You do need to know this rule though, that in order to minimize cost production or to minimize the average cost, the average and the marginal cost have to be equal to each other.
They have to be producing that many bags every day?
Every day or every year or every month, however they measure it.
Okay.
Yes. Okay, yes.
How do they get the part where you have like C5 equals CX, like 4x?
This?
How do we take the derivative equals 0, like we're gonna see this problem?
Derivative equals 0 gives you the derivative at the point because you're evaluating the derivative 0 at the point of 100,000 bags in the prior example. This time, we don't know how many bags there are.
Because it's not looking for minimum point, it's looking for minimum cost.
Minimum cost. So we're looking for where the derivative matches the average. So we have to set those two functions equal to each other,
Because that's what it said on the box.
right? So in example 1, we know how much the bags are. So then we are solving for the derivative at that point. Here, we don't know what the measurements are or what the x is. And so the cost function could be up and down. And so we're looking for where the average of the cost matches up with the derivative. And there will be some visuals later on. But today's not that day. Yes, sir.
It says where the average cost would be the smallest, so why can't we just like set it equal to 0 and then find the unit?
Because your average cost will never be $0 to make a bag.
Because you can't have negative money to be countering the positive money.
Because you could make 0 things and spend no money. That's the logic. But you have to say, okay, if I make 0 things, then I also make 0 money, but I also spend 0 money. So you have to make something in order to make the money. Okay, let's look at another business concept here. The demand function. The demand function is represented as the price per unit, where we have little p as the price that the company charges when they sell an X number of units. The revenue, so their income, is represented as capital R, price per unit times the number of units they sold. The marginal revenue cost is the derivative of the revenue function. Okay, so to maximize the profit, our marginal revenue must equal the marginal cost. So here is some things to think about. The profit is made by taking the revenue, your income, and subtracting the cost of actually making the thing. When I take the derivative, what I'm saying is take the derivative of all of these functions. Where the profit has a critical point, meaning where its derivative is 0, that means that the revenue derivative must equal the income or the cost derivative. Okay, so profit is your income minus your cost. Where the profit is 0, the derivative of the profit is 0 represents the peaks and valley of this function. Where it's 0 is where the revenue and the cost have a matching derivative. Get off your phone. Okay. Looking at this as a big picture, Howard's Hamburger has a yearly demand function of P equals 800,000 minus X over 200, and a cost function of C of X equals that number. Now, I have the cost function. I have the price per unit function. How would I find the revenue? In order to maximize profit, I need to know what is the revenue function. Look at the top of the page. How do I find the revenue function? Right. What's another way I could do it? Right there. Your revenue, your income is the price for one thing times the amount of things that you have sold. So this is going to be 800,000. How many? 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. X minus X squared all over 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. To maximize profit, I need the derivative of the profit to be 0, which means I need R prime to equal C prime. This is the concept I'm following. Your profit is revenue minus cost, so their derivatives should be equal to make this 0. Looking at C prime will probably be the easiest one to do. C prime is just 0.42. The derivative of the revenue function, split this into 2. This is going to be 4x minus x squared over 3, 4, 5 zeros. So our prime will be 4 minus x over 1, 2, 3, 4, 5 zeros. Did we follow that? Here is C, here's C prime. Here is R, here's R prime. I'm setting them equal to each other. Yes, we're good? Nodding? Okay, and we're solving for X. What is the quantity we need to sell in order to maximize our profits? So I will have 4 minus 0.42 times 1, 2, 3, 4, 5 equals X. How many burgers are we selling? A couple? Yeah. This is in a year. How many burgers we're selling in a year? $358,000 burgers. Okay, so this is number of burgers per year for max profit. Okay, if I know what the sale price, or sorry, how many I'm going to sell, how much money will Howard make if he does this? Yeah, now I need to use the profit function, right? How much profit will he make? Well, I need to do P of X equals R minus C. And then I input X equals 358,000, right? So let's zoom out here and see what is my R function. 4, 3, 5, 8, 1, 2, 3, minus 3, 5, 8, 1, 2, 3, all squared over 2,000. Not 2,000, sorry, 200,000. Okay, so this is my R minus my C. 125,000 plus 0.42, 3,500, Here, done. So this is R, this is C. And I can simplify and I can collect like terms, but why would I? Just chuck it in your calculator. Yes, ma'am.
I have a question. Why don't you substitute the value of X and the P equals? Why don't we like use PX equals R minus C if we have like PX function?
What's the PX function? What are you looking at?
It's like demand function.
Demand function is small p. Small p represents the price for one burger. Capital P is profit, and profit is R minus C. Does that answer your question? Okay, so we are looking at capital P, the profit, 358,000. How much money will Howard make at the end of this year if he sells 358,000 burgers? I'm going to just stare at you until you give me an answer. How about that? Oh, good. Practice, practice, practice. It should be 6 figures. Pardon me? We're not going to play the guessing game. You guys are going to tell me. This video can be 20 minutes or it can be 45 minutes. You decide.
45 minutes.
All right. Well, we'll make it 45 minutes while I wait for you to put this in your calculator.
Is it 515,820?
Wow, $515,820. So he's going to make about $500,000. Yay. Okay. These 2 questions are what I would consider on the easy side. This is why I said pay attention. This is where it gets difficult. Let's do example 3. This is the more challenging question. And hint, hint, nudge, nudge, it's a good question. Okay? This is also an outdated question, but we're just going to pretend, okay?
Let's see.
A store has been selling 200 compact disc players. You guys know what that is?
Yeah.
CD players. Do you guys ever seen one?
Yeah.
Oh, look at you. You can consider yourself old. Congratulations. Okay. So the store has been selling 200 compact disc players a week at $350 a piece. Okay, I'm going to highlight some things if my pen will work for me, please. Here we go. Highlight this. This is the selling price. This is small p. Okay? Oh, my pen. Come on, pen. Work with me here. This is little p, right? This is the price per unit, the small p. Okay, now 200 compact disc players a week. This is, I'm just going to give it a number, N, which equals the number of CDs sold. Okay, a market survey indicates that for every $10 rebate, the number of sets sold will increase by 20 a week. So I need to make a list of information stuff that I have. Excuse me. Do you guys know what a rebate is?
Yeah.
What is it? You get money back. What's another way to say something when you get like money back or you're paying less for something? A discount. Let's call it D for discount. Okay, so this will be the number of $10 discounts that the store will do. So if D is 1, that means we reduce the price by $10 one time. If D is 3, then we reduce the price by $10 3 times. Therefore, the discount is now $30. Does that make sense? So D is how many times are we going to allow this discount to occur? Let's say X is the number of CD sold. And P of X is, well, we know the selling price. So we have to put some things together. According to our equation, or sorry, according to our question, I'm going to call this number 1. the number of CDs sold is what right now? 200. However, it will increase plus by 20 for every time we reduce the discount. So if we reduce the discount one time, we get 20 extra sales. If we reduce the discount 2 times, we'll get 40 extra sales. Do you understand what I'm saying? Okay. When we look at the profit, let's call this, how do I do this?
Don't we need a demand function?
We do need a demand function. That's what I'm going to try to.
Starting price first, so we just need to buy this.
Okay, yeah, let's take a look at the selling price. So let's rearrange this. P of X will be starting at 350.
Times X, 350X.
Not yet.
Why not?
This is the price for one thing. The price for one thing right now is 350. How are we changing it? Minus 10D, right? We're reducing it by $10, D number of times. We got to figure out how many times do we need to make the discount. Okay, are we following this so far? So we are using the information given and setting up some equations. Now I need to have all my equations with one variable in it.
D equals 2x minus 200 over 20, so you can sub that into the PX.
Okay, let's solve for D. So using equation 1, D equals x minus 200 over 20. Are we happy with that? Okay, now if I substitute this into number 2, the price of the product, small p of x is 350 minus 10 times x minus 200 over 20. And to make my life simpler, I'm just going to expand all this. 350 minus x over 2
Minus 100
plus
plus 100.
100. Okay, and simplify further.
450 minus x over.
Minus x over 2. Okay, this is my price function. Okay, I want to, in part B, we need to finish answering part A. This is our demand function, price per unit. It wants us to find the revenue function, R. What's the last thing I have to do? Times everything by x. So my revenue function is 450x minus x squared over 2. In part B, how large should the rebate be in order to maximize revenue? So here I'm looking for the critical point of the revenue function. So what do I need to do? Say again? R prime equals 0 is what we're going for. Okay, we want to find what are the critical points when R prime is 0. We know what R is from part A, so R prime would be 450 minus X. So X is 450. This is telling me I need to be able to sell 450 discs in order to maximize my revenue. Sure, let's check. Let's check if this is appropriate. So check R prime of 400. and compare our prime of 500. If I put 400 into here, I get a positive number. If I put 500 into there, I get a negative number. So this is a max. That is confirmed. Okay. What else do I need to do? I've been told the number of this. I want to know the price. You can put it into equation 1 directly, and then we can solve for what the discount is. Yep. So let's see. We would have equation 1 says 450 equals 200 plus 20D. So this is 250 over 20. 12.5 equals D. What does that mean in like actually?
So you get 12.5 discount, but that wouldn't work.
Okay, so this means I have to reduce
To the lowest.
the price by 10 times 1250 to maximize revenue. Right? So my price would be 350 minus 10, 12.5. So what's my new price? No, it's not negative. What would be my new price? 225. That's how much they should cost to maximize the revenue. Okay, part B, not so bad. Part A gets people every year because setting up those two equations is challenging, apparently. So in order for you not to follow the pattern of former years, you must do all these questions. Practice, practice, practice. Understanding the difference between price per unit, i.e. the demand function, the cost function, the revenue versus profit versus marginal cost. You need to have that language, that business economics language down pat, okay? We are done.